Now we're going to do a problem where we have the quotient of two binomials that contain radicals. This involves a few special tips. Let's read our helpful hint. When the denominator of a fraction contains a radical expression, we multiply both the numerator and denominator of the fraction by the conjugate of the denominator. So it's very critical when we do this problem that we find the conjugate of the denominator and we multiply both the numerator and denominator by that conjugate. Let's see how this works. We notice that the denominator is 5 plus the square root of 3. The conjugate would be 5 minus the square root of 3. We want to be sure we multiply that same expression on the top. So we have here some binomials that we have to multiply out. One binomial times another, so we use our FOIL method. In the numerator, when we multiply the square root of 3 times 5, we get 5 times the square root of 3. For the outer product, we get minus the square root of 9. For the inner product, we get plus 20. And for the last term, we'd have minus 4 square roots of 3. This is multiplying these two binomials on the top. How about the two binomials on the bottom? The first terms would give us 25. The outer product is minus 5 square roots of 3. The inner product is plus 5 square roots of 3. And the last term is minus the square root of 9. So in our numerator, we see that we could simplify 5 square roots of 3 minus 4 square roots of 3 is 1 square root of 3. We notice minus the square root of 9 is minus 3. And in our denominator, we have 25. We have plus 5 square roots of 3 and minus 5 square roots of 3, so that's just 0. So we have 25 minus the square root of 9, or 25 minus 3. If we do a little simplifying, plus 20 added to negative 3 is 17. So we have 17 plus the square root of 3 in the numerator, and 25 minus 3 is 22 in the denominator. Our final answer is 17 plus the square root of 3, all divided by 22. When you do problems like this, be sure you're starting correctly in that first step by multiplying the numerator and the denominator by the conjugate of the denominator.